let's say that maybe you forgot how to factor and you've got an upcoming test soon. This video will help you with factoring. First off, I'm going to remind you what factoring is. Let's take a number, say 30. That's a good number. In order to find the factors of 30, we have to find two numbers that multiply to 30. This can be quite a few numbers, so let's draw a table first. So, two factors of 30 would be 1 and 30, because 1 times 30 equals 30. Other factors include 2 and 15, 3 and 10, so on and so forth. So, in order to factor a quadratic equation, which is a little bit more interesting, we need a quadratic equation. So here's a good one right here, x squared minus x minus 2. There will be more coming on the way. So they'll set out some certain scenarios that are a little bit more annoying to deal with. So in order to figure out what the factors of this quadratic are, first thing we're going to do is we're going to draw an x. Big old x in the corner here. Then we take the coefficient of this first term here. This is 1. There's nothing here, so it's 1. And then we're also going to take the last term, which is negative 2. We're going to multiply them together and put them at the bottom of the x. And then you're going to take the middle coefficient. That would be a negative 1. So, then you need to find numbers that multiply to negative 2, but add to negative 1. So this is where part of finding factors of normal numbers come in handy. So finding factors of negative 2, you've got 2, negative 1, negative 2, and 1. And that's about it. If you add these together, then it'll equal 1 and negative 1. So these are our clues to finding our factors. So we'll put these over here for now. So, in order to actually find our factors, and there is technically a shortcut. If your first coefficient is equal to 1, then you can stop here. Your factors are x minus this number, or x plus this number, so x minus 2, and x plus this number, so x plus 1. And those are actually the factors. But if you don't have 1 in the coefficient, or if you don't have 1 as the first coefficient, then we'll have to do something a little bit more convoluted. So first thing we're going to do is we're going to take our first quadratic and move it down here. We're going to get rid of the middle term, though. That's not very important. So x squared, and leave a little bit of room, and minus 2. You're going to pair the bigger numbers here with the smaller numbers. We're going to put x's on either side of these, by the way, just so that it's a bit easier to do. So you pair the larger number and the smaller number. So now we're going to find the factors of these two equations, right here, x squared plus 1x and negative 2x minus 2. So finding the factors of these, it's a little bit trickier, but it shouldn't be too hard. If you find the greatest common factor between both terms. So for instance here, your factors here are x and x, and for here, 1 and x. Our greatest common factor is x. So, we're going to write an x right there. That'll be important just a bit later. Over here, our greatest common factor is -2. So we're going to write -2 over here. Now, since our greatest common factor is x, we're going to divide both of these terms by x. So we'll get x plus 1. And then, same with over here, we're going to take our number here and divide both terms by that number. And then we get x plus 1. Here's where we find our actual factors. If these two numbers equal the same, then you did it right. That's one of our factors. And then the other factor are those two terms added together. So x minus 2, x plus 1. And we can check this by foiling, which is multiplying the first numbers, the outer numbers, inner numbers, and then the last numbers. So the first numbers, you get x times x, plus the outer numbers, x, plus the inner numbers, so plus -2x, and then the last numbers, plus a -2. And then when you simplify all this, it turns out to be x squared minus x minus 2, which is our first quadratic. Here's a special case. Here's a special case. The reason why this is special is because if you notice, every single term is a square. 4 is the square of 2, x squared is the square of x, and 25 is the square of 5. And there has to be a minus here. We're going to do a factoring method known as difference of two squares, hence the minus here. When you have a difference of two squares, if you take both sides and put them under, well, it doesn't have to be both sides, but whatever, under a square root, then you can get 2x minus 5. This is one of our factors, and our other factor is 2x plus 5 every time. Now this only works if every single number in the quadratic is a square. So for instance, 3x squared minus 8, that wouldn't work because those aren't squares, but 4x squared minus 9 would work. It'd be 2x plus 3, 2x minus 3. This last form of factoring I'm going to show you is going to be a little bit unconventional, but it's going to be a lot better for messy quadratics. This is the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. This is under the guidelines of ax squared plus bx plus c. So this is a little bit less conventional, but it works out a lot better for some not so nice quadratics, such as 28x squared plus 26x plus 6. Doing all sort of factoring on this is going to be really, really annoying. So instead, we're going to mark our variables. A equals 28, because 28 is there. B is 26, and C is just straight up 6. Now we don't need this. So we're going to focus purely on this, and we're going to take all of our variables here and plug them in over here. So negative 26 plus or minus the square root of 26 squared minus 4 times 28 times 6 all over 2 times 28. So this can be rather intimidating, but with a calculator, it's no problem, really. Going through all of this, you get negative 26 plus or minus the square root of 676 minus 112 times 6, which is equal to 672, all over 56. Now these are still some pretty big numbers, but if we subtract these, you notice that's equal to 4. That's very, very easily square rooted. So, what we have now is negative 26 plus or minus the square root of 4 over 56. So, what this means is you have negative 26 plus 2 over 56 and negative 26 minus 2 over 56. And doing these, it's equal to negative 24 and negative 28. And when we simplify these numbers, they come out to be approximately, or exactly, negative 3/7 and negative 1/2. So these will show our answers. These are what x equals. If we want to find our factors this way, then there's a little bit more that we have to do. So we're going to make two equations here. X equals negative 3 over 7. X equals negative 1/2. So first thing that we do is we have to try to get this to set equal to 0. So first thing we're going to do is we're going to get rid of the denominator by multiplying this side of the equation and this side of the equation by 7. So times 7 we get 7x equals negative 3. And if we simply add 3 to both sides, we get 7x plus 3 equals 0. This is our factor. Same deal over here. So times 2 times 2, get 2x equals negative 1. And if you add 1 to both sides, you get 2x plus 1 equals 0. And that's our other factor. Now, again, there's a simple way to check this. And that is, again, by foiling. So we take our first numbers, 7x times 2x, equals 14x squared. But here's a problem. 14x squared does not equal 28x squared. So where did we go wrong? The truth is, we never went wrong. The problem was that for our quadratic equation, one of our factors was x equals 1/2. This is due to the fact of simplifying fractions. Now, if we want to get the proper factor for this, it needs to be 2/4, negative 2/4. Negative, it's meant to be negative. Then our factor would be 4x plus 2. If we take 4x plus 2, and check with using our FOIL, find out that 7x times 4x is 28x squared. And we do our outer, 7x times 2x is 14x. And inner, 3 times 4x, 12x. And then 3 times 2 plus 6. And this gives us our total of 28x squared plus 26 x plus 6. Factoring with the quadratic formula is usually not advised. Unless you have a really big quadratic, then the quadratic formula will basically never be used. But you are actually not supposed to use the quadratic formula for factoring, and that problem is the reason why. Instead, you're supposed to use it to find your zeros, and your zeros are equal to x equals negative 3/7 and 1/2, negative 1/2. And so that is what the quadratic formula is meant to be used for. It can be used for factoring, however, just a little bit unconventionally.